first in a series of videos meant to instruct you about vectors as a mathematical concept. So that's going to look at what vectors are and what kinds of problems we can solve with them. We're going to begin in this video by looking at some basic definitions to get a fundamental understanding of the vocabulary we'll be using with vectors, as well as some of the more introductory concepts. Physical quantities can be represented in two ways: scalars and vectors. Scalar quantities only have magnitude associated with them, but vectors have magnitude and direction. So a scalar quantity for speed might be 40 kilometers per hour, but a vector quantity for velocity might be 40 kilometers per hour north. Vectors can be algebraic or geometric. We'll focus on geometric for this. A geometric vector is represented by an arrow. The arrow head indicates direction, while the length of the arrow shows the magnitude of the vector. This geometric way of representing vectors makes it very easy to compare them, both in terms of direction and in terms of relative size. If we have a vector starting at the origin and ending at a point A, the name we give for it is OA, or we can occasionally label it as just vector A. These two notations are used to indicate the name of a vector. With the bars on either side, it indicates the magnitude or size of the vector only. If you use the vector notation that only uses a single letter, you can pick any letter you want to name the vector, like you would a variable. In general, if you use points, they should be written in the order that the direction of the vector indicates. So in this case, it would be AB. This vector originates at the point A, and it terminates at the point B. So its name would be AB. Now I spoke about being able to compare vectors. The two vectors at the top are equal because they have the same direction and same size. However, the two vectors below are not equal because they do not have the same direction or the same size. It is worth noting that the vectors on the top and bottom of these four are also not equal. They may have the same relative length, but they don't have the same direction. In order for two vectors to be equal, both have to match. Of course, vectors of equal length still have connections to each other. Here we have vector AB, and the other vector would be called BA. And so these vectors are equal in magnitude, but opposite in direction. And so what we would write is that AB is equal to the negative of BA. A negative sign implies that you have a change in direction from what the vector states. So as soon as you throw a negative in front of BA as a vector, it implies that the direction is actually going A to B. Here we have an example to test your knowledge. ABCD is a square where vector AB is equal to vector P, and vector BC we're going to designate as vector Q. We're going to write vector expressions for the following: vector CD, vector AD, and vector CB. We're going to write those in terms of vectors P and Q. Pause the video now to give this one a shot on your own and resume it when you're ready. So the vector CD I can see is the same side of the square as BA, so I know those two vectors are equal. And BA is just the negative of AB, so I know that CD is equal to the negative of P. Vector AD happens to be the same vector as BC, and so I know then that that is equal to Q. And now vector CB is just the reverse of BC, so it would be the reverse of Q, or negative Q. That's the end of this very brief introduction to vectors. There's many more topics to be covered in the remaining videos of this playlist and exercises in your textbook to practice.